As we look forward to the future, most projections have significant increases in world population, significant increases in per capita energy requirements, as well as food requirements are also going to go up. So technologies that can supplement the need for all of these things simultaneously is a benefit. IH2 technology is one such technology which allows the conversion of a relatively broad spectrum of both agricultural as well as forestry products, as well as municipally derived residues, into renewable hydrocarbon fuels.
By the mid-century, we're going to see over 3 billion more people in the middle class. The middle class is going to have increasing appetites for mobility, for the shipment and transport of goods, and that means a growing demand on the need for transportation fuels. One of the real virtues of the IH2 technology is its ability to convert a wide array of biomass resources into the same high-quality finished product. And that means economies can use what they have locally and turn that into the fuels that they need for their transportation sector.
As the population increases in the world, the transportation fuels demand also goes up. And producing the transportation fuels from renewable sources is a welcome step in the world.
The IH2 process is primarily composed of 4 different elements. The first element is biomass conditioning. The second element is what we call the hydropyrolyzer, and that's the heart of the IH2 process. This hydropyrolyzer is actually what sets the IH2 process separate from the other biomass conversion technologies and helps it achieve unparalleled efficiencies and effectiveness. The IH2 process is self-sufficient and does not require any external input of hydrogen.
The reactor used in the IH2 process allows us to bring hydrogen along with biomass and proprietary catalysts, which undergoes a series of hydrodeoxygenation reactions to yield pure hydrocarbons.
Well, the IH2 process is actually quite feedstock flexible. It can convert a variety of different lignocellulosic biomass feedstocks, and it can convert all of these feedstocks to high quality oxygen-free hydrocarbons, which can either be finished fuels by themselves or they can be high quality blend stocks. The process also produces very valuable byproducts such as biochar and high quality aqueous product.
Over the last 4 years, we've operated our pilot scale facility. We've kept it on stream for well over 6,000 hours now, and we've demonstrated that the process is stable. We've demonstrated that the catalysts are stable and remain highly active over an industrially relevant period of time. Once you reach thousands of hours on stream, you answer certain questions that you simply cannot answer any other way.
6,000 hours of operation at the pilot plant have allowed us to learn a lot about the process. It has helped us put together the right protocols. It has allowed us to build the expertise we're going to need to use as we go into demonstration scale of this process.
The catalyst has been improved significantly. When we started, our product was a little bit off color. It was a little orange, maybe a little yellow. Now it's water white. It's amazing the transformation we've made.
The liquid hydrocarbon fuel that we generate at the pilot plant meets the domestic and international fuel standards.
One extraordinary aspect of the IH2 process is that while the science involved is quite revolutionary, the chemistry is quite extraordinary. The components are relatively conventional. The technology and the systems that we need in order to construct these plants will be available in a wide range of contexts and in many different communities in many different places around the world. This is a process that quickly and directly gets you from the solid biomass feedstock to fuels that are chemically identical to the sort of fuels that we're putting into our tanks and our engines right now.
IH2 is the most exciting technology I have ever worked on in my entire career, and I'm very proud to be a part of it because we've taken it from a little idea that we had, very bench style kind of tests, and brought it all the way up to a continuous operating unit that runs all the time, and now the demo unit is just the most exciting thing I've ever seen. It's had the intellectual workings of all these different people with different ideas, different backgrounds, all working together to bring this to fruition.